Good morning and welcome to our webinar on understanding closed captions and establishing best practices for FCC compliance. My name is Steve Holmes. I'm a senior video application engineer here at Tektronix. If we take a peek at the overview of the rules, back in 1993, the FCC set out requirements for all analog televisions that were 13 inches or larger that they needed to be able to display captions. Then progressively through 1996, 97, the FCC set out different transitions and schedules that people who made programming, the VPDs, needed to be able to provide captioning. And then in 2002, the FCC set out for digital TV for those receivers to also include closed captioning. If we take a further look at the rules, in January 1, 2000, they mandated that at least 450 hours of material be captioned. In 2002, it went up to 900 hours. 2004, 1,350. Then we walk our way all the way down to 2008, where 75% of all programming, including the pre-rule non-exempt programming, must be captioned. So currently there are two categories of exemptions from the closed captioning. One is a self-implementing economic burdensome, which you need to be able to prove. And then the other is the time period between 2 a.m. and 6 a.m. Those are the two pieces of the captioning where you can get exemptions. Then, with the new rules that everybody is talking about on February 20th, 2014, the FCC set the new and improved rules so that we could further define, and these basically dealt with the quality of the closed captions. So, with the new rules, it got into stating that the captions must be accurate to the spoken words in the dialogue, and it needs to convey all of the background information as well as other sounds to the fullest extent possible. The captions must coincide with the people speaking. So when the people are on screen and they are speaking, the captions need to be in sync with the spoken words. The captions must run from the very beginning of the content all the way to the end to the fullest extent possible. And then must be properly placed on the screen so that they don't block anything. Basically, the top third, the middle third, or the bottom third is how they're typically run through here. And if you look at some of the words in this, I love the fullest extent possible. So they really give you really finite definitions of what we need to do. So we have the ability to be able to turn on captions. They need to be able to be on the screen and be viewable by the viewer. So in the workflow that we've got for producing closed captions, we start out with a 608 cap file, either an FCC or a .cap file, put that into the closed caption inserter, which also upconverts the 608 to a 708 caption. It is not a mimic file. It is a full-blown 708 caption insert. And then we go out to the transmission chain, and if all things fall in place, we have captions on the screen. At a future point in time, we will discuss what happens with our over-the-top content and the new rules and regulations for over-the-top content in SMPTE time text. But for today's presentation, we're just going to sit with 608 and 708 captions. So in our workflow, we need to be able to create the caption file that it will play to the content time code. Create both the 608 and 708 portions and place that in the 708 CDP, Caption Data Packet. We need to be able to insert the captions into the video. Then the video at some point will be transcoded to the desired output type, quite often that output type will be further encoded for a distribution content and then distribute the content. In the distribution part of that, quite often the content will be repackaged for some other HD presentation or down converted for SD reception. So a lot of content starts at life as 1080, but it may be airing on a 720 network, so the HD would have to be cross-converted. And if you think about cable, cable has both a HD tier and an SD tier, so all the material typically shows up on both, even if it's only produced in HD. And then we need to be able to deliver that content to the consumer and have the captions be able to appear on the screen. The top part of this, the first three, really deal with the new Title 47 checks. Really, the onus is on when the captions are created that all of the quality aspects take place. But it doesn't remove anybody else from the window of the burden of proof. So then in the transmission chain is where I've included the transcode, the encode, the distribution, the repackaging, and then the delivery of the content to the end consumer. So if we take a look at that transmission piece, typically there's some FDI component in there someplace. It's either coming off of a MES file, being ran out in SDI. We are going to take that, we're going to ingest that, transcode that, and then we need some form of file-based monitoring to verify after the SDI has been verified that these 608 and 708 are both present and that we have met the Title 47 requirements. In the file-based monitoring, we need to make sure that we have not mangled the captions and the captions are still intact. Then in the distribution chain, we still need to be able to monitor all the way to the end of the system that we are delivering captions that are reproducible on the consumer's screen. The CEA 708 defines the digital television closed captions, 708 captions. They defined a backwards compatibility within there to where we will carry a complete 608 payload along with the DTV-CC payload, what we commonly call the 708 payload. That's carriage of the 608 is for down conversion. If we have a down convert from HD to SD, either, say, grandma in her little $50 set-top box or at a cable venue that is providing a SD tier, they didn't want to put the onus on the down converter or the set-top box to have to be able to try to parse the 708 captions and try to make 608 out of something that looks completely different than the 608 payload. The 708 captions are a windowed-based captions where I could have up to 8 windows on the screen for a single service. The windows could be different colors, they could have different fonts in them, and they could be placed anywhere on the screen. It was too hard to try to take that and down convert that to a 608 payload that we could reinsert on line 21. So that's why they decided to include a 608 native caption payload in the stream, so we could just grab that caption payload, take it, down convert it, take that payload, put it on line 21, and on our SD sets we'll have captions. Then we take the 708 payload and we take that directly to the HD receiver. On HDMI and captions, one of the things you need to remember in troubleshooting is that HDMI does not carry captions. The captions come in external to the video into the set-top box, or in the case of Blu-ray player, on the disc. It is the job of the set-top box to overlay and burn in those captions into the video that is placed onto the HDMI. The HDMI has no provisions for carrying captions as a independent payload. All it carries is video, and then the video will have the captions burned in on top of the video. So any device that you have that makes HDMI and takes in a signal and makes HDMI out of it, it is the responsibility of that particular device to place the captions in the HDMI video and burn them into the video. So within our 708 CDP here, there are two data rates that must be maintained throughout the transmission chain. The 608 channel has a data rate of 960 bits per second. The 708 channel is 10 times bigger at 9600 bits per second. And those data rates must be maintained through the transmission. So that means that video at different frame rates, different styles, need to still package the data correctly. So what we end up with is, for, let's say, a 1080 transmission, we insert the captions only in field 1 at the frame rate of 2997. But in a 720 broadcast, we're going to insert the captions still in at frame rate, but the frame rate happens to be 5994. So the amount of data in a 720 package has to be half the amount that's sent in a 1080, because we're sending it twice as often, because we still need to maintain that 9600 bits per second throughout the entire time we're doing this. We've all seen several different issues with captions. Probably the most common is just absolute absence of captions at all. Some of the other issues we quite common in thing are garbage captions or garbled captions, which in a lot of cases happen to be captions on top of captions. Within the 708 caption, there is no timeout for the captions to automatically be removed off the screen. So if something happens to the captions where we miss a window clear or a toggle command, the captions will stay on the screen into the next scene. We see this quite often when commercials sometimes cut in too early, and you lose the last couple frames of video that would have had the clear command to take the captions off the screen, and the captions continue on into the commercial. So with the 708, with 608, they automatically time out and they will remove themselves off the window, off the screen. But the 708 captions will stay on the screen until somebody physically sends a command to remove those. So that's why you see some really bizarre things. So within live video, if you do not have the clear command, captions will stay on through the next scene. And I'll talk more about this as we go on. The other things that are very common is you get a piece of captions and then you get nothing but a blank line, as if nothing at all was sent. In most cases, there's data there, but the data got mangled or a character got set that made it impossible for the displaying device to actually display the captions. The one on the bottom with 708 captions, there are multiple fonts, multiple font styles that can actually be set. And in this case, the second line that went out was set to small font, but the caption decoder did not know how to rekern the font, and it kept the spacing based on the first line. When it presented the second line, it made the font small, but it didn't know what to do with the actual spacing of the fonts to actually close the space together. So you see all the spacing on the black background, and it looks like there's garbage in between the characters, but it's actually part of the video that's actually showing through. All three of these shots have been off of live recordings that I've actually recorded and troubleshot. So for video programmers and people delivering video to the end consumer, we have an FCC obligation to pass the captions of already captioned programming. We need to create requirements to adhere to best practices for testing and quality control processes. We need to have a procedure in place for performance requirements are met. We need to QC the tape and file-based materials and the SDI material that we are going to present before we air the material. We need to verify the presence and the accuracy of captions in real-time events and convey that information back to the captioner if there are problems, and provide relevant materials for materials that you're producing now and going to have captioned, because the new requirements say you must explain what is going on to the fullest extent possible. We need to create a best practices guide for troubleshooting caption issues, then log any issues and relay them back to the caption vendor or the provider of the material, and maintain a list of contacts that is easily accessible for people to be able to do this. So within the SDI domain, the file-based domain, and the transmission domain, there's several different pieces of this that we can look at. So if we take a look at the SDI domain, we need to verify that the SD and the HD portions of the captions, i.e. the 608 and the 708 captions, are both present in the content. It is mandatory per the standards that both payloads be included. We need to check for the new rules and do at least spot checking for accuracy, that it's synchronized to what's on the screen, and the program completeness, that it starts at the beginning and runs all the way to the end of the material. In the old days with old 608 captions, it was fairly simple to verify that our captions were in, our captions were correct, because we could go to line select on a waveform monitor, we could walk back to the 608 captions, we could verify that the run-in was in the right place at the sine waves in the beginning of this, at the timing between the leading edge of sync to the center of the leading edge of the run-in was absolutely correct. Were 50 IRE, they were sitting on the zero line on the bottom going up 50 IRE, and if we met these criteria, the captions would be displayable on any decoder there was. Then we could also look and see how many services we had. Did we have CC1 and CC3 or just CC1, and be able to do this. But in the 708 SDI domain, the captions are actually included as part of a vertical interval data packet. It's up in the bank. The issue with this is one data packet looks like every other data packet. It isn't necessarily just as simple as going into line select, going back to line 9 if that's where you're placing your captions, and verifying that line 9 has data on it, because you honestly do not know what that data is. Every one of these three data packets look almost identical, and you'd be hard-pressed to tell me which one of these was captions and which one of them was something else. And if you look on the bottom picture, you'll see that one's line 9, and there's two data packets on the same line right next to each other. So within our waveform monitors, we need to be able to set up multiple video windows and verify that, yes, and we do indeed have our 708 captions and our 608 captions. And within at least Tektronix waveform monitors, we have the ability to put up 4 caption windows at one time. So if you were doing twin language, let's say English and Spanish, you could verify that the 608 had both services in it and the 708 had both services in it, and the text in both services in both transports were in time with each other, and be able to monitor all of it. Also, on a side note, if you look at the 708 window, you'll notice that the font is fractionally smaller than the 608 window. And part of that reason is that 708 allows more characters across the screen than 608, but you'll almost never see this used because all captions, at least to date, start their life as 608 captions, and are up-converted, if you will, to 708 captions. Now, these up-converts are not 608 mimics. The up-conversion actually makes a full 708 payload. It is no different than if you authored this from scratch as a 708. There is really no such thing as a mimic within 708. You have 708 captions, you have 608 captions. It's just how were the 708 payload created. So within the picture, we have a lot of issues that can take place. The captions could be mangled. We need to verify the services that are in there and the captions that we see that go on screen, and did we end up with Klingon on the screen? And if we did, why did we do this? Also, if you notice on the window on the right-hand side in the bottom, the auxiliary data status window, that in the 608 service, we have both CC1 and CC3 being sent, so twin languages, most likely English and Spanish. And in the 708 payload, only service 1 exists. This is actually technically a violation, because think about it. If someone was in their kitchen and viewing captions on a SD monitor in, let's say, their kitchen, and they happen to be watching the Spanish captions and have Spanish captions overlaid, they go walking out to their living room or family room, turn on their big TV, their HD set, and pull up the captions, they would have no Spanish captions on the second TV set. So that's why it's mandatory that both services be carried. We have done what we can within our waveform monitors to take that black line that we looked at earlier, and if there is text that was actually in that line, but it wasn't able to be presented because of a formatting issue, to be able to show you the text that should have been there. So at least within a Tektronix waveform monitor, we actually take the text and we'll put it on the screen, on the waveform monitor, in red, and then tell you in the error log of the waveform monitor that the text was there, but there was something wrong with it. It was obscured from being able to be displayed on the screen. And in the case of this actual video here, the reason this was obscured happened to be that the font came up as a black font on a black background. And with a black font on a black background, guess what you get? A black line. So, but the text was actually, in real life, was actually there. Now, the problem with this is that about 50% of the devices out in the field, out in the world, do not know to put up a black font, and they will put up everything that's sent to them in white. So you are going to get, in this particular case, a mixed report back. You look at an SDI monitor, and unfortunately, 3/4 of the SDI monitors will also always show white fonts. They will not show you the black line. So your SDI monitors will be lying to you in most cases, not telling you that you actually have a legitimate issue that's going to cause customer complaints. Also, within the world, most of the material that is not live and not sports starts out its life as 1080i content. So a lot of the 720 material that airs starts its life out as 1080i content and needs to be cross-converted from 1080i to 720. One of the easiest ways to cross-convert material, if you are not going to run it through and reflip it, is to set up a playout device, set the output of that playout device to 720, set up a second device to record that 720, and then a lot of people try to just take the line 9 data, which is the captions, and copy it across. The problem with that is that you will have 1080i captions sitting in your 720 material, and instead of sending out 9600 bits per second, you're going to be sending out 1400 bits per second in the caption channel, and you're going to OD most caption receive buffers. In this case, what you actually need to do is cross-convert the video from 1080i to 720, and you also have to cross-convert the caption data packet and repackage it from a 1080i packet to a 720 packet so that it can be put in twice as often but only have the correct amount of data in it each time that it is inserted. This is where I'd say the majority of 720 problems exist, is in doing this. We can look at the material as it goes out and see what line and what field the caption's actually in the picture here. If you look at the 6101, the one that's highlighted, 6101 is the DID and the SDID for the 708 packet. Happens to be on field 1, line 9. And then we can look at that packet if we want to expand the screen, put it up full screen, and actually see the hex dump of the data. There's really only a couple of things that we really need to look about in that hex dump. One happens to be the DC, or the data count. How many bytes of data is being sent? And are the CRC checksums okay, or is the data being mangled? Within the 708 CDP, there is actually different amounts of data that can be sent. So you have the raw caption data itself, and then we have different types of service information that can be added to the captions. The service information ends up with different numbers of services. So you can have the raw captions with no service data at all, and you'll have the character or the CDP links that I've highlighted in yellow. Then if you happen to have caption service information carried with that, then you can have different numbers of packets. I've only listed here from 1 service to 4 services. It can go way beyond 4 services. The problem gets into that a lot of post-processing equipment doesn't know how to handle anything past 3 services. So let's take the example of the 720 broadcast. If you have a 720 broadcast with no service information, you'll be sending out 43 bytes of data. If you add service information to this, depending on the number of services that you are sending along as ancillary data, you could have, let's say, 3 services and have 66 bytes going out the door. If you go beyond that, there is a pretty good chance that post-processing gear that is looking at ancillary data in the transmission chain of the SDI is going to start mangling the data. It's just kind of what happens in the world, unfortunately. So here's 3 different data dumps. The first one is a raw dump with only 43 bytes, no service information. The second one in the middle has 59 data bytes, so there's 2 services being indicated. You can see the packet got bigger. And then the third one is actually one in error, where it did indicate 3 services from a link perspective, but the last service was 100% nulls. The people that put this in thought, well, maybe they want to include another type of captioning service or indicate some other data, and they just made the space and they put in nulls. This actually made a network start having issues. Whenever a scene change came up, the processing gear would start dropping frames, and the typical frame that it happened to drop happened to be the frame just before a scene change. The frame just before a scene change happened to have the toggle and clear commands. So that meant that the captions never got removed off of the screen from the previous scene. The new scene came up, the new captions came up for the new scene, but there was already captions on the window. And they ended up with captions on top of captions, looking like mangled captions. This took a very long time to troubleshoot down to a root cause, but it was very, very unique. So if we move from the SDI domain to the file domain here, when we transcode the material, ingest the material, get it ready to be placed on our air chain server, we still need to make sure that the 608 and the 708 captions are still intact. We can check for over 30 different types of syntactical and structure issues that make sure, so that we can make sure that they have not been mangled in the transcode and the data is still in place and intact. So within a file-based system, typically we run those off of watch folders on a file QC system, where you have your material come into a watch folder. The QC system gobbles that up, checks it, and verifies it, generates a report, moves it off to a pass location, gets the next file in, tests that file, then turns around, generates a report, moves that file, in this case, off to a quarantine location because there was an error, sends out an email to somebody that this file has failed the QC process, and in this case, it was a caption failure. These systems also do video quality at the same time they're doing the captions, but in this case, the 708 Service 1 contained no information for 97 seconds, almost a little bit over 97 seconds, where the value within the template said anything over 30 seconds of no captions, I need to be notified of. So then with the file-based systems, you can bring the file up within the viewer, and in the case of the Aurora system, we can bring the file up in the provided viewer that is a full-featured viewer, the Hydra viewer, and actually view both the 608 portions and the 708 portions of the captions. So you can change the viewer to which caption payload and which caption service you're actually looking at. One of the things I want to notify you of here is be careful of VLC in doing this. VLC, at least within the last load that I looked at, only looks at the 608 payload of the captions. Yes, it will put captions on the screen and it will overlay captions on the material, but it is only decoding the 608 payload, and you can't verify that both payloads are actually in the material. So be a little bit careful when using other types of viewers. You need to be able to specify the channel that you want, the 608 or 708, and the service within those specific channels when you're QCing the material off of an error. So if we move out to the transmission domain here, again, we need to verify that after we've done everything that we do to the video, that the 608 and 708 captions are both still intact and in the stream. We can check for over 15 different types of syntactical and structure errors, as well as the percentage of time within a block of time that the captions are present to make sure we are meeting our obligations of the total of 75% captioning of all material. And then we can also view this off of an IP interface, an ASI interface, a QAM interface, or an 8BSD off the air, and verify that the captions will be viewable by the end user. One of the things that I have found in troubleshooting things is looking at a feed. In this case, there are mangled or bad 708 captions, but one TV is displaying the captions just absolutely fine, and another TV is displaying no captions at all. Please remember that the TV is not responsible for displaying these captions. It is the decoding box, or the box that is taking the output and putting it onto the HDMI signal. A lot of cheaper, smaller set-top boxes don't want to deal with the complexity of 708 and parsing 708 and properly positioning 708 and put it on the screen. So some of those boxes actually only decode the 608 channel when you set them up for captions. Some boxes actually do the actual true 708 payload part of the captions. When you get into this situation, you'll have multiple types of indications coming back where not everybody is having an issue, but X% of boxes or X% of customers are complaining about bad caption issues. You have to try to duplicate these conditions to the fullest extent possible, even down to the model of set-top box within the same manufacturer, because some of them do it differently. Some of the issues that we can look at in the transmission chain is, well, the top one has to be the percent of content that is actually captioned, to make sure within a given amount of time, a week, a day, a month, couple months, that we are maintaining the 75% or greater captioning. The 608 payload within the 708, that it has not been in error, has not been mangled. The 708 portion of the 708 content within the 708, that it has not been mangled and there's not illegal structure sitting inside of that, and that the captions would be then viewable actually on the screen. Then we can actually go into interactive displays, actually look at blocks of time and verify that within a given amount of time, look at what is my 608 payload looking like, what is my 708 payload looking like, and am I meeting the requirement for both the 608 and 708 captions being in on my HD screens. Theoretically, all digitally coded material is supposed to have 708 captions. Even SD material digitally coded is supposed to have 708 captions. But in today's world, as long as captions appear on the screen, the FCC really doesn't care how they got there. As long as the customer can go in on an SD set, pull up captions and see captions, on an HD set, pull up captions and captions appear, you are in compliance. That's why it's set to best practices. There is no actual qualifications for this stuff. We can then highlight and mouse over one of these blocks and actually look at a block of time, and it will tell you what was going on with that. We can also generate reports for given lengths of time and customize these reports. In this case, this is a report I made for doing FCC compliance, covering dial norm discontinuities, i.e. dropouts in the video, as well as closed captioning. And I set up closed captioning to look at, to make sure that everything was captioned greater than 85% of the time, and nothing was less than 85% of the time, which when I monitored this service over the hour of time that I was pulling, it was fully in compliance. If we have issues, we can turn around and set up alerts that are sent out and within these systems, and generate emails for captions missing for X amount of time and how many times within that period of time, and it occurs each time or only after X number of times within a given period of time, and actually generate alarms based on that. If you notice a pattern has been determined that every week this one show comes up, I'm having an issue with this one show every week at XYZ time, you can turn around, make a capture of that show, record off about 5 minutes of the show. That's more than enough time to be able to analyze this or send it off to somebody to have them look at their content and figure out what's going on. If you need to be able to do this, you may have to get some tools that are capable of digging deeper into the material and see what's actually going on with the material, so that we can turn around, and once we have a pattern determined, we can turn around and post-analyze this with a protocol analyzer, say like the MTS 4000, or we can turn around and do a deep dive actually on the captions themselves to see what was actually in error with this. Within the stream analyzer, they will bring up and tell you if a service has been captioned or not captioned. If you look at the top left block, you'll see that there are absolutely no captions at all in the service. The second block on the right only has 608 captions, and the bottom block has absolutely no captions at all in it. If we need to look at issues that are display issues where the captions are indicated there in the screen, but they are not being displayed correctly, we may need to break this down and look at further analysis of the captions. Here's a feed we did assisting a customer where their 608 captions were being displayed correctly right off the go and had no issue at all. The 608 was set for pop-on with black text, actually white text on a black background, and the 608 captions as normal were popping on the screen just fine. We rolled to the 708 captions, same exact piece of video, and there were absolutely no captions being displayed on the screen at all. And again, this only caused issues in some pieces of material being viewed, or actually in some customers, because of some devices grabbing the 608 payload and some grabbing the 708 payload. If you look at the 708 window on the far right-hand side, there is a little tab in there that's called visible, and it was marked no. That exists because the captions are being sent a few bytes at a time, so you are supposed to build up the entire paragraph or the entire statement to be displayed on the screen. When the entire paragraph is made, then a command is supposed to come down to toggle that byte and then place that data on the screen. And as of late, I have seen several transmissions go out where the captions are sent, they go into the buffer window, but they never get displayed on the screen. The captions are sent, they go into the buffer window, they never get displayed on the screen. Captions are sent, and just randomly they get placed on the screen. So you get what looks like garbage captions or garbled captions, but in reality, they are not being displayed. The problem that I have seen is not all devices go by that visible indicator or not. And a lot of devices look at this and see the captions all the time and will display them regardless of what the visible indicator shows or doesn't show. So when we look at the captioning, we can actually look at the on-picture display. We can see the text buffer window, which is where the text is being built in before it's being displayed on the screen. Watch it come into the buffer window, watch it move from the buffer window to on screen. We can select which one of the services that we want to actually show on screen and actually verify the 608 is being presented correctly, the 708 is being presented correctly, as well as be able to look at the window parameters or any other piece of information that actually pertains to building these captions, and look at what is actually being sent in the stream. Is the 608 and 708 in there? Is there XGS data? Is there AFD data? What are those particular pieces of data actually indicating? The other thing that we can look at quickly here is the data and how it is packed in, let's say in this case, an MPEG-2 stream, since 90% of our content to date is still MPEG-2 as the final delivery to the customer. How the data is actually packaged and being presented in the MPEG stream will determine, in most cases, whether it's decodable or not. The file on the left, the actual caption data, is sent after the extension start code, but just before the picture data. There is an area within an MPEG stream that is the user start code or user data, and we place the data in there. It's almost like placing it in the vertical interval in SDI. The problem is the caption decoders look for the first packet of user data. If the first packet of user data is not captions, they skip right down and start decoding the picture data. They don't examine every single packet of user data to see if it is, in fact, their captions. It takes way too much time and too much processing power for most set-top boxes to be able to do that. And if you kind of look at this picture, you can kind of ID why. They would have to actually scan down through each one of these hex bytes to actually find the proper start code, which is the 47, 41, 39, 34 that you need to see that actually indicates that this is my caption payload. And you would have to scan that byte by byte to actually try to find that pattern. And most set-top boxes do not have that amount of power that they look at the first one. If the first one's not it, then they just start making pictures. I hope this presentation has presented some good usable information to you. We will have some follow-up emails with some application notes that you can be downloaded that go into a little bit more detail on some of these pieces. And for some of the questions that you have, we will try to answer a few of them here online with the time we have left. But all of the questions will be answered and emailed back to everybody. So I want to thank you very much.